Okay, in this last video for section 1.4, I want to go back and try to bring the other two videos together for you. It was a lot of information covered. We covered signs and ranges of trigonometric functions, as well as those basic identities. And now we want to just work a few problems to put all that knowledge into working order for you. So I'm going to pull these out of your textbook, but they're going to give you a very basic one that's I've sort of done before, but we're going to go back and look at it. Suppose that angle theta is in quadrant 2 and sine of theta is equal to 2/3. What they want you to do is they want you to find the other 6 trig values. Okay, so I'm going to draw a picture first off, and I always recommend you drawing a picture just to know what you're looking at. We're in quadrant 2, and so we know a lot about quadrant 2 already. We know that sine and its reciprocal cosecant are positive in quadrant 2, and everything else should be negative. So we know sine and cosecant should be positive, but our other answers should be negative. Now I'm going to draw that angle, and remember we always draw back to the x-axis to make that perpendicular line to the x-axis to make that triangle. Never draw to the y to make that triangle. Now sine of theta, remember, is y over r. That's right and crazy out there. But y then is 2 and r would be 3. So we need to find that other side. Well, x squared plus y squared is equal to the radius squared. This is old Pythagorean. Maybe not old. We're going to fill in. X squared is what we're looking for right now. Y is 2. The radius is 3. So we have x squared is equal to 9 minus 4. I'm just multiplying this out, moving it to the other side. X squared is equal to 5. So what we really want is x. It is the square root of 5. And noting we're in quadrant 2, this is going to be negative. So I'm going to mark this as negative square root of 5. And we all know that once we find that triangle, it is just downhill from there. We can just pick off those values without any trouble. So let's go ahead and lay them out. We know sine of theta is 2/3. Cosine of theta is x over r by definition. So cosine of theta is going to be negative square root of 5 over 3. There's one. Tangent of theta is y over x, as long as x is not 0. So tangent of theta in our case is going to be 2 over my x, which is negative square root of 5. Well, there's one that we have to, scoot this down a little bit, that we have to make rationalize. So I'm going to multiply by the square root of 5 on top and bottom, which gives me that the tangent of theta is going to be negative 2 square root of 5 over 5. Well, let's make life easy and use some of our theorems that we had earlier. We can use the reciprocal property. If sine is 2/3, then cosecant of theta is the inverse, or the reciprocal of that. It would be 3/2, and I don't have to do any work on that. If cosine is negative square root of 5 over 3, by the reciprocal function, then secant of theta would be negative 3 over the square root of 5, which we would have to rationalize. So secant of theta would be negative 3 square root of 5 over 5. And then finally, if tangent, I'm going to go up from this top one. If tangent is negative 2 over square root of 5, then by the reciprocal of that, cotangent of theta is going to be negative square root of 5 over 2. And I pulled it off of this first one right here because I knew I could flip that over and then not have to rationalize. So cotangent is negative square root of 5 over 2. Now let's think about this. Are sine and cosecant positive? And we have a definite yes. Positive 2/3, positive 3/2, they're reciprocals. Are all of my other values negative? And indeed they are. And so we're done with that one. And we've used our reciprocal properties as well as our sign properties to keep us in check. Okay, let's do another example. It will take me just a second to find it on my paper, and then we will be good to go. This one is going to use a little bit of a different approach, but similar concepts. What we want to do now is we want to find sine of theta and tangent of theta, given that we already know cosine of theta is equal to a negative square root of 3 over 4, and sine of theta is greater than 0. That is, it's positive. Now, again, we could draw this just like we did before. We could look at our quadrants. But this time I want to take you from the standpoint of using an identity. Now, what we have is a given piece of information. We're going to have to involve cosine somehow. And we have two pieces of wanted information. So I'm thinking through my identities, and I need to link the given with just one piece of the wanted. I don't want to use both because having two unknowns makes life too hard. So I recall that my Pythagorean identity states that I know sine squared of theta plus cosine squared of theta is equal to 1. That involves my given piece here, cosine, with my wanted piece, sine. And it doesn't involve tangent, so I don't have too many unknowns floating around. So let's see if we can get sine out of this without too much trouble. This is sine squared. I've got to get that down to sine in a minute, but we'll get there. Now remember I told you that cosine squared of theta is the same thing as that being squared all together. I can replace cosine of theta with a negative square root of 3 over 4 because that is its value. I'm just taking cosine of theta and what it's equal to and putting it in that place. Now I'm going to work this out. I have sine squared of theta plus, if I square off the negative square root of 3, I would just get 3. And if I square off the 4, I would get 16. Notice that will turn positive because you're squaring a negative. Solving for sine squared just means I'm going to subtract my 3/16 from both sides. So sine squared of theta is going to be equal to 13/16, and I did that by getting a common denominator. Remember, 1 is the same thing as 16 over 16, and so that is where I worked there with that common denominator. And then lastly, I'm going to square root both pieces so that sine of theta is equal to either positive or negative square root of 13 over square root of 16. This square root can be broken up. I'm just trying to fill in some algebra rules for you. It can be broken up, but the square root of 16 is just 4. Now, remember they told me which one I needed. They told me sine of theta needs to be positive. So my answer here is that sine of theta is going to be positive square root of 13 over 4. I have sine of theta, I have cosine of theta, I still need tangent of theta. So this part, we worked with the Pythagorean identity. The next part for tangent is going to be worked with the quotient identity. And the reason I know I want to use quotient is because sine of theta over cosine of theta is something I have, and I'm looking for tangent of theta, and I know those are equivalent. Sine of theta is the square root of 13 over 4. Cosine of theta is negative square root of 3 over 4. All of this should equal to tangent of theta. My pen is not aligning right now, guys, so I'm kind of writing out there in the midst. Hang with me. I'll try to pull it in and see if it helps any. Now, if you have forgotten how to divide fractions, remember you keep the first one, you change your division to multiplication, and you use the reciprocal, there's that word again, of the second one, or the divisor. Alright, 4 goes into 4 one time, and 4 goes into 4 one time. So multiplying across, I get square root of 13 over square root of 3. I'm pulling my negative to the front. I need to rationalize this. Square root of 3 on bottom and square root of 3 on top. That is going to give me the square root of 39 on top and 3 on bottom with a negative. And I think that that is going to be it. This is tangent of theta. So I can just write tangent of theta is this. Okay, so both of those problems are examples of ones that you may use. We've used one that was just straightforward. We drew a picture as normal. And then the second one we used and tapped into a few more of those identities to just give you a feel for what is going on.